Hi and welcome everyone. In this video, I want to go over the real zeros of polynomials. So let's go over this theorem that's called rational zero theorem. So what it says, it's if the polynomial p of x equals to a sub n x to the power of n a plus a sub n minus 1 x to the power of n minus 1 plus dot 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 plus a sub 1 x plus a sub 0. So basically that's the general form of presenting a polynomial. And just know this number is the constant, and it's called, sometimes in some books you're going to see p or the constant coefficient, and this one is LC or Q, which is the leading coefficient. So it says has real coefficients where the leading coefficient and the constant coefficients are not zero, then every rational zero of p is of the form p over q, or the constant coefficient over the leading coefficient. So that's how the zeros are going to be. Now p is the constant coefficient, as I've told you, or we call it cc, and that's what I use most of the time, or a sub 0, and q is the leading coefficient, and it's lc, which is the same thing as a sub n. So those two. Now let's look at this simple example. I have a couple of them. This is a linear equation and it's a polynomial. When you put equal to 0, when you solve this, you get negative 3 over 2. And again, it's the form of constant coefficient over the leading coefficient. And it's negative because it could be positive or negative. For this one, so if x squared minus 4x plus 3, that's a quadratic equation. So you can solve this by factoring, so you get 1 and the other one is 3. Now if we go here, the constant coefficient is 3. The possible factors of the constant coefficient is plus or minus 1 or plus or minus 3. The leading coefficient is 1. The possible factors are plus or minus 1. So the possible zeros of that polynomial, if we haven't solved it, we know it's going to be the ratio of the constant coefficient over the leading coefficient. That means that over that, plus or minus 1 divided by plus or minus 1, or plus or minus 3 divided by plus or minus 1. So you kind of list all of them, and that's going to give you the possible zeros. And here, as you know, as you see, we got 1, which is 1 over 1. And here 1 over 1 is just 1, so we got that. And 3 divided by 1 is 3, and we have the positive 3 here. So basically, when you start solving a polynomial or putting it equal to 0, one way of solving it is find the possible zeros and proceed from there, see which one is going to be the 0. And you do that by synthetic division, which is coming. So now this is not Descartes' rule of sign. Let me go over these two, then we'll do some examples. Now we have p of x, a polynomial with real coefficients. The number of positive 0 of p of x is equal to the number of variation of signs in p of x, or less than that by an even whole number. So be patient, I'll tell you, I'll try an example. The number of negative real zeros of p of x either is equal to the number of variation of signs in p of negative x, or less than that by an even whole number. Now this example can illustrate that. We have a polynomial 2x to the 4th power minus 3x to the 4th power plus 4x squared plus 4x minus 1. You count the variation of signs. So from here, this is positive and that's negative, so 1 variation. Then it's from negative to positive, that's the 2 variation. Here sign doesn't change because it's positive to positive, and here it changes, so we have 3 variation. So the variation of sign positive to negative or negative to positive, that's what it is about. We call the variation of sign. And here we had 3, so I wrote it here. We have 3 variations of signs, therefore we're going to have 3, or the even integer is 3 minus 2, 1 positive real zeros. Now you find p of negative x. P of negative x will also change the sign of the coefficient of the odd exponent. So if you want to do that fast, because negative x to the 5th power is still negative, stays negative. So p of negative x is negative 2x to the 5th power. Here it doesn't change, minus 3x to the 4th power plus 4x squared minus x, and that changes because it's x to the power of 1. If you put negative x, that becomes negative minus 1. The variation of signs here, none. Here we have 1, here we have 2. So we have 2 variations of signs. So therefore, you're going to have 2 or 2 minus 2 is 0, negative real 0. So if you get a number, let's say if you got 5 variation of signs, the possible number of zeros are going to be, well, if it's for p of x, it's going to be 5, 3, or 1. You each time take 1, and that's what is going to give you. And I put note p of negative x is to the power of negative x to the 5th power minus 3 negative x to the 4th power plus 4 negative x squared plus negative x minus 1. So, and again, these stay negative, and the positive ones, they don't change, they stay positive. For this one, 2x to the 6th power minus 3x to the 5th power plus 4x squared plus x minus 3. If we use Descartes' rule of sign, we have 1 variation of sign because that's positive. Start from the beginning. Here we have 2 because it's negative positive, here none, and here we have 3. So, and then we put that number here. So we have 3 variations of signs. Therefore, we have 3 or 3 minus 2, 1 real 0. So this polynomial is going to be 3. It's going to have 3 or 1 positive real zeros. If I didn't tell you, this is for positive ones. P of negative x is 2 times x to the 6th power plus 3x to the 5th power, because that changes. And that's going to change also, but that stays the same. I'm talking about the signs. So we have 2x6 plus 3x to the 5th power plus 4x squared minus x minus 3. And if you do no variation of sign, no variation of sign, here we have 1, and that's it. So we have 1 variation of sign. So for sure, we're going to have 1 negative real 0. So now if you want to find these are the steps to find the zeros of a polynomial. So list all the possible zeros. So the possible zeros, again, this is the constant coefficient divided by leading coefficient. All the possibilities. I'll show an example. Then divide, synthetic division until the remainder is 0. Be patient, I'll go over that. And repeat 1 and 2 until you reach to a quadratic factor. And you can find the quadratic equation by using the quadratic formula and do it. Let me go over this example, and don't worry about that number. This is a good example. Let's go over this. So we have 3x cubed plus 5x squared minus 2x minus 4. We want to put that equal to 0. To find the possible factor, the possible zeros, first write the constant coefficient is -4, and all the possible factors of that, which is plus or minus 1, plus or minus 2, and plus or minus 4. Then write the leading coefficient, and that's 3. Then the possible factors of 3 are plus or minus 1 and plus or minus 3. So, and I put the Descartes rule of sign here, but we don't have to worry about that. So let's just find all the possible zeros. The possible zeros are going to be plus or minus 1 divided by plus or minus 1, which is plus or minus 1. Then we have plus or minus 1 divided by plus or minus 3, which is plus or minus 1/3. Then we have plus or minus 2 divided by plus or minus 2, which is plus or minus 2. Then we have plus or minus 2 divided by plus or minus 3, which is plus or minus 2/3. Then we have plus or minus 4 divided by plus or minus 1, which is plus or minus 4. And finally, we have plus or minus 4 divided by plus or minus 3, which is plus or minus 4 over 3. These are all the possible zeros. And which one is going to work? You have to do the synthetic division. Start with the easiest one. I picked 1. So synthetic division, you can make the box any way you're comfortable. So the way it works, you put all the coefficients. So we have 3, 5, -2, and -4. 3, 5, -2, and -4. Very important. If a coefficient, a term is missing, make sure to put 0 when you do the synthetic division. So 3, you bring the 3 down. First step, then you multiply 1 times 3. You write the answer here is 3. Then you combine 5 plus 3 is 8. Then you multiply again. 1 times 8 is 8. -2 plus 8 is 6. 1 times 6 is 6. -4 plus 6 is 2. And we have a remainder. So this is out. We know 1 is not a 0. X minus 1 is not a factor. Let's try -1 now. Same thing. You write all the coefficients. Bring 3 down. -1 times 3 is -3. 5 minus 3 is 2. -1 times 2 is -2. -2, -3 is -4. -1 times -4 is 4. -4 plus 4 is 0. The remainder, this is the remainder, and it's 0. So you know x plus 1 is a factor. Now, how do you write this? You can write the original polynomial and write x plus 1 times. These are the coefficients of the factor. So it's 3x squared plus 2x minus 4. And in this case, we got the quadratic. So don't do synthetic division again. Just go ahead and solve this by using the quadratic formula. And if you use that, you get that answer. So we have our 3 zeros. The degree of this polynomial is 3. If you and you have 3 zeros, and that's how it works. If it's 4, you have 4 zeros, and sometimes you don't get all real zeros. You can get complex zeros. So, and this is an irrational 0 because you have square root of a number that is not a perfect square. Now, the lower bound and upper bound, we don't have to worry about that in this lecture, but maybe for this is just finding the possible zeros. I just want to see if we have another example. Let's try this one. This is another example. X cubed plus 2x squared minus 13x plus 10. One more time, you write the constant coefficient, which is 10. You list all the possible factors of that, plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. The leading coefficient is 1, so it's plus or minus 1, the possible factors. Then you write all the possible zeros by doing the constant coefficient divided by the leading coefficient. So it's plus or minus 1 divided by plus or minus 1 is plus or minus 1. Plus or minus 2 divided by plus or minus 1 is plus or minus 2. Plus or minus 5 divided by plus or minus 1 is plus or minus 5. And finally, plus or minus 10 divided by plus or minus 1 is plus or minus 10. Possible zeros. Then you do the synthetic division. Start with 1. Write the coefficients 1, 2, -13, 10. -13, 10, bring the 1 down. 1 times 1 is 1. 2 plus 1 is 3. 1 times 3 is 3. -13 plus 3 is -10. 1 times -10 is -10, and you get 0 here. So then you can write the polynomial as x minus 1 times x squared, because that's 1, plus 3x, because that's 3 minus 10. Again, these are the coefficients of that quadratic factor. And you can factor that and just put it equal to 0, and you can list all the 0. Again, the exponent is 3, and we do get 3, 0, and these are all 3 real zeros. I think that's good enough for this lecture. There are more examples you can take a look at, but these are pretty straightforward. Make sure to do more examples so you can be comfortable with this. Thank you for watching, and I'll see you in my next video. Have a good one.